Okay, hello everyone. This is another additional video to helping you solve some problems in Chapter 3. So let me start with the questions. Yeah, let me write the question. This is about the related rates. Okay, let me go through. Okay, this is the questions. Okay, so let's read carefully. Okay, an observer stands 300 feet from a hot air balloon. So it's a hot air balloon that is raising upwards at 20 feet per second. So this is 300 feet. So you have a person standing next to the hot air balloon in the distance of 300. The hot air balloon is raising upwards. You have a specific rate. And what rate is the angle? So you need to check the angle between the observers and the balloon. Okay. When the balloon is 400 feet above ground. Okay. So please pause the video or stop the video and check your results. Try to solve this question. And at the end, let's compare our results. Okay. Okay, to begin with, we can start with drawing the rough sketch of our diagram. So maybe we can make our person here, and then this will be the line of sight. So maybe like that, and maybe making it more downwards like that. And I will have my balloons here. Okay, now this will be 300 feet, and it's going up. Let's say this is y, so our dy over dt will be 20 feet per second. So remember that this have rate of change, and also we are going to determine the angle theta. Maybe angle theta is here, and this is the one that we are looking for, d theta over dt. So we have a constant 300, okay, and we have a rate of y or dy over dt, right? So we have 300 y and theta. So we will have, if we draw the triangle, we have 300, we have y, we have theta. So the best way to approach this is relations between these three is by looking at the tangent theta is y over 300, right? Okay, we can have several methods, several approaches to derive this tangent. We can derive directly. Tangent become secant squared, and this will become 1 over 300 and then dy over dt. And we need to find the secant theta from here when y is 400. And this will be 500, right? So secant is 1 over cos, or cos is 3 over 5, so this will be 5 over 3. So we can write down here d theta over dt become 1 over 300. Multiplied with dy over dt is 20, and then square root as not square root squared of 5 over 3. This become 3 over 5 squared. Can we check? Let's check. This cancel. It's 15. So it become 320 So 1 over, let's say 1 over 15. This will be 9 over 25. Okay, so this will be 3. This will be 5. This will be 3 over 125. Is this correct? I think, wait. Okay, let's check with other method. Okay, we can also write this in terms of tangent inverse of y like that, and this is our theta, and we can take this approach and make it to d theta over dt is 1 over 1 plus this whole, and then multiply with the chain rule. It's 1 over 300, and then dy over dt. So d theta over dt is 1 over 1 plus, this is at 4, and then 20 feet per second. So we can check this. Oh yeah, it's 25, 5, yeah, it's the same. Okay, so I think we have our answer. That is 3 over 125, around. Or this will be a radian per second. Yeah. So we can have two methods. Okay, this is the first method, this is the second method. Okay, so that's the results. Okay, so if you, okay, so how about your calculations? Is it same? Okay, let me look for another question as well. Okay, let's move on. Let's try to okay, next question. Okay, this will be let me write down the question first. How many lines are tangent to both parabolas? Y equal -1 negative x squared and y equal 1 plus x squared. Find coordinates of the points at which tangents touch the parabolas. Okay, now we have this problem here. We have two parabolas. So the first parabola is -1 negative x squared. The other one is 1 plus x squared. Okay, to understand the problem very well, we need to take approach to draw maybe the roughly sketch of these two parabola. Okay, so stop the video if you want to try solving this by your own, and then let's compare the results after we finish. All right, now let's start to draw the diagram, draw the curve. Okay, so essentially, if you're wondering on how to quickly draw your curve, looking at this two, let's start from the right one here. 1 plus x squared. Okay, you have an essentially the x squared. You know that, right? You can draw easily, and maybe you can draw that in this part here. we call this our first curve, that is x squared here means we just have a basic function x squared, and then we plus with 1. So we move the x squared upwards 1 unit. Okay, so here is the vertex now. So we have, this is 1, okay, 0, and then here we are moving downwards, but we have a negative. The negative means we need to reflect the function, right, about x-axis. Okay, that means this will resulting on, let me take this and let me make a copy. Let's imagine that it is our parabola. So this will be -1. Okay, so we move 1 unit downwards from the vertex. Okay, now the questions is asking how many lines are tangent. So we need to imagine there will be a line. Okay, there will be a tangent line that connecting these two curves. So the first thing is probably the line we will be having this here, and another line will be here. Yeah, it should be the should be around here. Okay, now we need to figure it out. What is this line here? Let's take our point here as P and Q. Okay, and then take the P and Q as we can have a variable, another variable, maybe A. Okay, maybe A. So we can have this. This is A, and the Q will be precisely symmetrical, and it's having -A. Okay, so we can have, at P, at P this will be A and a 1 plus A squared, sorry, and at Q this will be -A and then -1 -A squared. Okay, now we have these two, and let's take this as our triangle. So let's take this and take this. So we can imagine and to find the slope of line PQ. Okay, so we will have 1 plus A squared, okay, and then minus -1 minus A squared, and divide by the delta x, which is the A minus and minus A. Okay, and this will resulting this will be 2 plus 2A squared, and then this will be 2A, or we can say that this will be 1 plus A squared over A. Okay, let's observe a functions that is 1 plus x squared. We know that if we have f prime at A, this will be resulting 2A. Okay, then this should be having the same slope as 1 plus A squared divided by A. Okay, solving these equations, we get 2a squared equal 1 plus a squared. So we will get a squared is equal 1. So a is plus minus 1. Okay. So the points will be a1 and a negative 1. So the point will be 1 and then 2. Okay. And the other one is negative 1, negative 2. And then the other points as well, we have 4 points. Okay. So we will have, so first is 1, 2, negative 1, negative 2, and because it's symmetry, we can say that the other one will be negative 1, 2, and also 1 and negative 2. So that is the 4 points. Okay. Well, if you want to take the other points, like for example, you take this maybe r and maybe this is s, you take the slope rs, you find the slope, that's still also fine, but I think we don't really needed that calculation, because in the end we are having a symmetrical point, right? Okay, now another questions. This is more about the differentials. Okay, so a window, let me write first, has the shape. Okay, now this is differential questions, still related to linear approximation. So let's read first the question. A window has the shape of a square surmounted by a semicircle. So you need to understand first how the figure looks like. Okay, so the figure, it should be like this. So you have a square, that square, okay, and it's surmounted by a semicircle. So you have a semicircle in top of that square. So you have a semicircle like that, and of course we see that most of the windows, they have this kind of shape, right? Okay, the base of window is measured by having width 60 centimeter with possible error in 0.1. So when x is 60 centimeter, our error or dx is 0.1. And use differentials to estimate maximum error possible in the computing area of window. So we need the area of window. The area of window. Okay, so in these terms, all the terms will be having an x because it has the error. That means it has a certain rate of change. Okay, and then we have also here x over 2. So we will have x squared, the area, plus the semicircle is half of pi x over 2 squared. Or we can write this as plus pi over 8x squared. Okay, now we have this. Now, to take this into our dA, our dA is our error in area, then we can differentiate and write down this as that and multiply with the dx. Okay, so we can compute at x 60, our dA or our dx is 0.1 and dA will be 260 plus pi over 8. This is also 260 and this will be 0.1. So we can say that dA can have the 2 for this case 12, okay, 12, 2 plus pi over 4, and then this will be 60 and 0, 1. So we can rewrite this in terms of 12 centimeter cube. So this is the maximum error. Maximum error. Okay, that's the differentials applications. Okay, so the differentials is actually if you have the y equal x squared, okay, and you differentiate this, find the first derivative. You know the first derivative is 2x, okay. But in differential, we write the dy is equal to x dx. So we are looking at the slight change in x, in which we can identify that in finding the error, okay, error in x. And if we are having a slight change in x, we have also slight change in y. That's how differentials works, okay. Okay, I think one or two questions more. Okay. The questions is about the evaluate. Let's try this. Try to check by yourself what's the results. Okay, this is limit, but it's actually derivatives. Okay. Okay. Now, if we are going to evaluate this, okay, remember that we have that definitions of limit. So we can have these definitions, right? So another way, this will result in the same thing as we are going to have this. And we evaluate it all in x equal 1. So we are having 17x 16, or we are having 17 as the results. Okay. Okay, one more. Still limit, but it's about derivative. So let me write this. Okay, try by yourself, and let's compare our results. Okay, now if you also remember, this is actually from another form of definitions, that is, this is h, this is f x plus h minus f of x. So if you're looking here, we have something 16 here. Okay, so probably this will be, let's say this is x equals 16. And let's just check when we have f of x is square with raising 4 square root. This will be x. Okay. Then if x is 16, then we get this result, right? We get this the original results, because 16 you are having a square with 4. This will be equal to, which is correct, right? And then we can say that the limit as h going 0 this is actually the same thing as we are having differentiations of this at x equals 16. We can take this and we can rewrite the answer 1 over 4, and then so it will be 4 and 8, and this will be 1 over 32. Okay. 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 I think last questions. Okay. Find dy over dx of x is from. Okay, stop the video, try by yourself, and see the results. Let's compare our results. Okay. Now first, we need to have let's just say that this we can start from here. Let y is equal secant x, and then with power of x, then we can have this approach here. We can have our friends ln to help, okay? And then we can have ln y is x ln and then secant x. Then we start to derive this, and we are doing an implicit differentiations, okay? We're doing implicit. This will be 1 over y, and then don't forget the y over dx. And then this will be using the product rule. We have ln secant x, okay, and then plus x, and then 1 over secant x, and d dx of secant x. Okay, this will be resulting. Let me write 1 over y dy dx ln secant x, and then plus x over secant x, and then secant x tangent x, right? This differentiation, and cancel this, and we can have dy over dx is y is secant x with power of x, and we need to multiply with ln secant x plus x tangent x, and that's the answer. Okay, now to see the what's the important thing here, every time you see an exponent like this, okay, or maybe 5 over x, or maybe 3 over x, or maybe 5 over sine x, every time you see any component like this, your result should be having at least the same form like this with other additional components. Look at this. Okay, we have secant x with power of x. The results will have similarly the same original functions, right? So that's you need to be clever. Okay, so if you have like maybe options in the A, B, C, D, you can look out for this one here, so that you can narrow your answers. Okay, so I hope that helps, and I think this will be the end of the video, and I will be making, I think, one more video if I have time. Okay, so see you soon, and bye.